Okay, we are looking at correlation and causation. So let's just look at the left side. Let's see. Correlation versus causation. How we get tricked every day by data. So correlation, Rainy Mont, will you read that? What the definition is?
Oh, I've been finding the slide. It's number 10, right?
Yes.
Okay, correlation. Two events or variables are related as shown in data.
Okay, so we have talked about correlation. We found the correlation coefficient, which was showing, how correlated they are. If we look back at this slide here, we found the correlation coefficient, and that tells you whether it's positive, negative, zero, or strong or weak. Okay, let's look at causation. Isela, will you read that one?
Two events or variables that have a cause and effect relationship.
Okay, so we think of causation as cause and effect. So correlation does not imply causation, is a commonly used phrase. Discuss what it means and sum up the meaning in your own words. So before I have y'all do that, I'm going to show you a couple of memes I found. Okay, so let's look at this one. It's not on your slides. So correlation is not causation. So let's look at what the two variables are. Ice cream sales and shark attacks. So do ice cream sales cause shark attacks? No. But in this, does it look like they might? Because they both increase at the same time and then decrease together? Julian, will you read the bottom part of that for us?
Both ice cream sales and shark attacks increase when the weather is hot and sunny, but they are not caused by each other. They are caused by good weather, with lots of people at the beach, both eating ice cream and having a swim in the sea.
Okay. So a lot of times with the news media, they give you a cause and effect relationship. They'll say this causes this, but it's not necessarily true, because just because things are correlated doesn't mean that one causes the other. So let's look at the next one. I like this one. So I told the cops, correlation does not imply causation. What does this one mean?
That just because how would you put that?
Let's talk about the little girl in the house fire.
She's smiling.
She's smiling. Why is she smiling? What, Carter? Oh my gosh. No, she wasn't. So she's evil eyes, right? And she told the cops, correlation doesn't imply causation. What does that mean? Why did she tell them that?
Because she knew it. Because she was
Because
there,
of
doesn't mean
effect,
she did it.
Yeah. But what do her eyes tell us?
Did it.
In her little smirk. I thought that was really cute. Okay, the next one. Everybody who went to the moon has eaten chicken. Good grief. Chicken makes you go to the moon? No, but it's funny. Huh?
I don't get it.
So all the people who went to the moon have eaten chicken. So does eating chicken cause you to go to the moon? Yeah. Yeah, let's look at the next one. Stupid human. Correlation does not imply causation. What do you think about that one? Did the cat do it?
Yes.
Probably, but he's saying, nope, I didn't, because correlation doesn't imply causation. Okay, I'm gonna do this one first. What's freaking us out here is that we found a correlation between owning cats and being struck by lightning. So what does that mean if he's freaking out by it? What is he implying? Or what is he saying that the graph implies? Yeah. Does that even make sense? So you're more likely to get struck by lightning because you have 3 cats. I don't have any, so I have no chance.
I have 3.
You have more of a chance than I do.
Yeah.
Or not. Okay, this is one of my favorite. But this is more like I'm going to replace work with school. Yes, I'm late for work. Yes, I have an iced coffee. But remember, correlation does not imply causation.
Period.
As I say,
I haven't heard it put better.
Isn't there somebody in here who would always bring some iced coffee and sometimes she'd be late? Yes. Bree, we love you. All right, so we are going to come back over here and rephrase. Y'all are going to type right here. Says correlation does not imply causation is a commonly used phrase. Discuss what it means and sum up the meaning in your own words. So as your table group, y'all are going to do that. So y'all talk about it as a table group.
I'm exhausted. Could you repeat what you said? I was reading the board. My apologies.
Okay, so let's talk about it as a group now. Tristan, y'all's group, could y'all tell me what y'all said? What y'all decided the meaning was of correlation doesn't imply causation? Okay, so if it looks the same on the graph, not necessarily cause and effect. Okay. Rainey Taylor, what'd y'all say?
Just because something looks like it's part of an effect does not mean that the other variable is the cause.
Okay, good. Emmy, what'd y'all do?
We said just because 2 things have the same relative correlation doesn't mean they call the causation factor.
Okay. All right. Julian, what about y'all?
Just because they're related, it doesn't mean that they have a cause and effect relationship.
Ooh, I like that one. Okay, all of y'all's were good, but I needed to type in something. So, Julian, will you read that again?
Just because they're related in the data doesn't mean that they have a cause and effect relationship.
Hey, all of y'all's pretty much said that? Would you agree? Just in maybe a different way. I did notice that a lot of y'all put that just because. And just because they have this doesn't mean that. So I agree with that. I am going to highlight this. Okay, let's look. The problem with correlation is that we often assume causation. When we think 2 events are cause and effect, we can be persuaded by correlated data into believing that we have proof of cause and effect. So here are some examples. Katie, will you read the first one?
Students at schools with uniforms have higher test results.
What do y'all think about that? We don't have uniforms, so what does that mean?
No, we're not a private school.
That we're not a private school.
We're not rich.
We're not rich. Does that mean that just because they wear uniforms, they have higher test results? No. Okay. The next one, Catherine, will you read that one?
Doctors noticed that patients taking a new vitamin live longer than the average person.
Okay, what do y'all think about that?
What is this one?
But the
What is the vitamin? Okay, good question. What else, Amy?
I said the vitamin becomes old, so it can't be new at all.
True. Well, they're talking about a particular vitamin.
Oh, I thought they were talking about never mind.
Like a new one that becomes old?
Yeah, because they said like a new vitamin. Well, you take a vitamin and then it gets old.
Okay.
What? Okay, it makes sense.
Okay, Sadie, what do you think about that one?
I know.
Don't know. That's okay. Anybody else have any thoughts on that one?
I think it's cause and effect.
You think it's cause and effect? But what do we need to know in order to determine if it's cause and effect? Huh? What type of vitamin? What else?
Maybe like results from it.
Actual results, yeah. Because all the time commercials, right? You hear commercials like you're gonna burn this much fat by taking this energy drink or whatever it is. So this one, a new vitamin lives longer. Well, what about the people who take the new vitamin are just in generally better health
Yeah.
compared to in poor health?
I was gonna say the vitamin A.
I mean, people that
Do what?
take care of
It's probably the vitamin.
Yeah. Okay. The next one, Carson, will you read that one?
Salesmen who attended a voluntary training sold more than salesmen who did not attend.
Okay. So did the training cause the salesman to sell more? What do you think?
I think that the salesman who did not attend gave the other salesman more of an opportunity to sell more.
Possibly. Okay, are there other variables to account for? Yeah, what would be some other variables? So that was one of them.
One could have been doing it longer and kind of know what they're doing.
How long somebody's been working there? Yeah, or just a better salesman who likes to go to every single training that there is versus a lazy one who just doesn't show up and do anything. Okay, everyday news articles report on data and claims like the ones above. The data and claims are true, but causation has not been proven. Discuss why variables in each claim above may not be cause and effect. Should underlying causes be part of the story? Okay, so we've already done that. We have already discussed each one of those. So let's go over to this other side. You can have correlation without causation. So that two variables could be correlated, but not necessarily a cause and effect. There is a correlation or relationship between the number of firemen fighting a fire and the size of the fire. The more firefighters at the scene means there is a bigger fire. However, this does not mean bringing more firemen will cause the size of the fire to increase. Interesting. All right, let's look at these three. I want you to discuss it with your table group. Decide whether it's a correlation or causation. Use your scribble tool to circle the one that you and your group have decided on. Read all three. Let's look at them together. Alyssa, will you read the first one?
A recent study showed that college students were more likely to vote than their peers who were not in school.
Okay, raise your hand if you think correlation. Raise your hand if you think it's causation. Okay, so we have some disagreement here. So does anybody want to explain why they decided correlation? Yeah, Carter.
I said that the peers who were not in school would have to directly affect the students who were in college that were voting, but they're not in. But since they're not directly affecting them, it can't be funded.
Okay, so if you rephrase it into saying this causes this, then we would see, does that even make sense? So being in college causes you to be more likely to vote. Is that true? Mm-mm.
Oh man.
Yeah, that was a tricky one.
But it said a recent study, so I was going off.
Exactly, and that's what news articles and commercials do, right?
Yeah.
They trick you.
Yeah.
Yep.
Yeah, they tricked me.
You got tricked. All right, let's go to the next one. Hayden, will you read that one?
Rivera noticed that there was more trash in the hallways after Monday than Tuesday.
Okay, raise your hand for correlation. Okay, raise your hand for causation. Be proud. All right, so why correlation? Does anyone want to tell me why? Rainey.
Because you can't cause. Wait, we talked about that.
Yes, yes.
Because the Monday can't cause more trash for Tuesday.
Can't cause more trash in the hallway.
Yeah, that made sense.
Yeah. So just because it's Monday or Tuesday, that doesn't cause there to be more trash in the hallways. What causes there to be more trash?
Kids.
The kids just throwing their stuff everywhere. Maybe on Wednesday, the principal comes around and yells at them and they pick up their trash.
Yeah.
You know?
They should do that.
Yeah. All right, so that is correlation. Abby Kate, will you read the last one?
You hit your little brother and he cries.
All right. What do y'all think about that one?
Like that.
Okay, raise your hand. Correlation. What? Raise your hand for causation. Okay, yeah. Yeah, because if you hit your little brother, that causes him to cry. Is that true for a lot of y'all?
Yes.
Yeah.
Look at your brother, it causes him to cry.
Just look at him.
Yeah.
I have little sisters, so they cry and
That is not true. Abby hits me all the time and it's not her.
Well, she's not your little brother.
You're also like
She's my.
much bigger
I'm,
than her too.
I'm the little brother.
Oh, okay. Okay. Well, you probably hit her back. No, you're good. That's good. I'm glad you don't hit her back. I'm the little sister, and my brother would hit me, and I would hit him back, and all he would do is hit me harder the next time. Oh, it was awful.
My sister's mean. She can flip me over.
Alright, let's look at the next slide. This is our last slide in this digital notebook. So let's look and see no correlation, positive and negative. One thing I do want to have y'all type on here. Underneath positive correlation, I want y'all to type something. As one variable increases, the other also increases. That is what a positive correlation does between the two variables. Let me make it bigger. Not that big. There we go. As one variable increases, the other also increases. That's what a positive correlation is. So then a negative correlation, let me delete that. As one variable increases, the other decreases. That is a negative correlation. Here, I'll move it. All right, so now you are going to work with your table group to drag and drop these items into the right type of correlation. No correlation, positive, and negative. We are going to go over it. So the graphs were pretty simple, right? This one is negative. I need to make this smaller so I can do this easier. Fit. Negative, positive, no, negative, positive. Okay. The number of days absent from school and grades. Raise your hand for no correlation. Raise your hand for positive. Raise your hand for negative. Okay. Negative correlation. That means as the number of days absent from school increases, your grades decrease. So that's how you would use this to help you. I'm going to make this like that. Okay. Distance traveled and the amount of gas in the car. Raise your hand for no correlation. Positive, negative. Okay. So as your distance traveled increases, the amount of gas in the car decreases. Makes sense. Number of pets a person has and the number of books the person reads. Raise your hand for no correlation. All right, that's everybody. Oh, I need to pull it over here. Income and education. No correlation, raise your hand. Positive, negative. Okay, so as your education increases, so does your income.
Yeah, we thought it was like the higher how much money you have, the better education you could get.
College-wise,
It'd be education would be like your independent variable. So that's the one that you say first. As education increases, then your income increases.
Oh, okay.
Okay, test scores and shoe size. No correlation? All right. Agreed. How tall a person is, then how fast they drive. No correlation? Raise your hand. All right. So we got our 3 there. Is that how many we're supposed to have? Okay. And then weight on a skateboard and the speed the skateboard travels. No correlation, positive, or negative. All right. So as the weight on the skateboard increases, the speed does what?
No, it would increase.
I thought it would
because the more weight you
Because it's going down the.
But did it say down a hill? No.
No, I'm basically going off of.
But like if he going.
So if it was still and he just pushes it.
Right. Yeah, just the momentum or just the force of your foot going back. Think about if somebody was really tiny on there and did their foot back, same amount of pressure as somebody who was big did their foot back. Which one's going to go faster? The smaller one.
But I thought they'd have like more.
But the bigger one has
But-
more power.
But we're not talking about power. We're talking about, we're not changing any other variable except for weight. That's the only variable that's changing.
Okay, Missy Saskia.
Yes.
What in the world are we talking about?
Okay, let's look at it again. Okay, so the weight on skateboard and the speed the skateboard travels. My husband and I actually had this conversation last night, and I was, asking him what he thought, and he was like, "Well, it would be negative because it's just your weight and travel, your speed. But if you go down a hill, then that's when things change because the weight going down the hill, it gets momentum faster, right?
Well, yeah, I guess.
Yeah.
Yeah. But we're only talking about no other variables changing. We're just on a flat surface. So on a flat surface, using the same force of the foot push, whether it's somebody who's small or big, the speed is going to decrease as the weight increases. That one's a tricky one for sure. All right.
So is it negative?
It is negative. Yes. Yes, yes,
Okay.
yes.
I was confused for a second.
Okay. Hours in the mall and amount of money spent. What do y'all think? No? Positive? Positive, yeah. Definitely. As the hours in the mall increases, the amount of money also increases. Okay, temperature and the number of number of people wearing jackets. There we go. Okay, what do y'all think? Positive, negative? Okay, raise your hand for positive.
Oh.
Raise your hand for negative. Okay, so as one increases, so as the temperature increases, what happens to the number of people wearing jackets?
That would also increase. That's positive.
Do what?
That was going off.
No.
Oh.
It's negative. Because he said also there's 4.
Yeah, isn't this negative?
You're also stupid. But he's common sense.
Hey.
So what? It just said temperature. This-
Yeah. But you gotta say, be quiet. Shh. As one increases, remember how we wrote this out to the side? As one increases, the other decreases. So as temperature increases, what's happening to the number of people wearing jackets? Is it also increasing or is it decreasing? It's decreasing. That one is a tricky one too. Okay, the last one, hours of studying and grades. Positive. The more you study, as studying time increases, your grades are going to increase. All right. You have an assignment I'm going to pass out and put on Google Classroom for those online.